Alrighty, we are taking a look at triangle properties. Specifically, we're going to be looking at segments within a triangle. So that's what we're going to be looking at today. Our objectives for today is that we want to be able to identify the basic terms related to segments within a triangle. And then we also want to be able to classify those, or basically just name them, to be able to use the different properties and stuff that's associated with them. So there's not a whole lot of work per se, but the vocab and the terminology is super important to know. All right, so first things first, perpendicular bisector. This might be something that's a little bit of a review, but perpendicular bisector is going to be a segment that is going to be perpendicular to a line segment. So you're going to kind of have a line segment here, and then you're going to have something that is going to come and be perpendicular to it. But if it's a perpendicular bisector, remember bisector splits it into two equal pieces. So we would say this right here is going to be the same thing as this right here. So that's what we would have for that. Now, in a triangle, when you have your perpendicular bisectors come together, I'm going to kind of try to draw the midpoints of each of these sides here. And so you're going to see those are all my midpoints. And then what's going to happen is when I draw a segment or a line that is going to be perpendicular to those sides, you're going to see that, and it's not going to be perfect because I'm not drawing them perfectly and everything, but for the sake of this video, we'll pretend that these are all perpendicular. And so you're going to see they're all going to kind of come and cross at the exact same point. And so that point, we call that the circumcenter. So the circumcenter of a triangle is where all the perpendicular bisectors come together. Now, the important thing about that is that there's a unique property, and that's the circumcenter theorem, and it says that each vertex, so the vertex is going to be the same distance away. So that means that this distance, and again, not perfect because of how I was drawing it, but all of those distances are going to be the same thing. So that's the circumcenter theorem. All right. You can also see that here on this triangle. So if I went ahead and did my bisectors, I could kind of put all my bisectors right here, and you're going to kind of see that this here is, oops, helps if I have my line tool. And so you're going to kind of see that this is going to come here, and this is going to come here, and then this bisector is going to come right here. You're going to notice that all of them are going to essentially be right on the hypotenuse of this right triangle. So that's just another example of where that circumcenter is. And again, same distance away from each of those pieces. All right. So let's slide down over here. So an angle bisector, very similar to a perpendicular bisector, but an angle bisector is just something that splits an angle into two equal pieces. And so when you see that in a triangle, you're going to notice that the angle bisectors are going to create what's called an incenter. So if I go ahead and I draw a bisector that is going to split this angle, you're going to see that they're going to all come together. And again, it's not perfect just because of how things are going, but you're going to see that they're all going to come together here right at the center point. And the incenter theorem is just saying that the distance to the sides, so this distance here, and this distance here, are all going to end up being the same thing. So that's what the incenter theorem says. So angle bisectors, where they cross, that's the incenter. The incenter to the sides of the triangle are going to be the same. And you can kind of see that again here in this example. So I'm going to go ahead and just kind of draw this. So angle bisector, and then you can kind of see angle bisector right there. And so that's where it's going to kind of put it right in the center. All right. And then we'll take a look at the altitudes. So the altitudes, an altitude is just a segment that's going to extend from the vertex to the opposite side, and it's going to be perpendicular to that opposite side. So that's what an altitude is. And so the altitude in a triangle is going to create, all of those are going to create the orthocenter. So this right here, when I go ahead and I draw this, I need to create it from the vertex, and it needs to be perpendicular. So that kind of looks perpendicular. This looks perpendicular here. And then this is gonna, it's not perfect, but that kind of looks perpendicular. And so that point right there is going to be the orthocenter of that triangle. So I'm going to skip over this other example here, and then I'm just going to jump down here. So median goes from the vertex to the midpoint of the opposite side. That's what a median is. And where all those medians meet is what's called the centroid. So midpoint to the vertex, midpoint to the vertex, and then midpoint to the vertex, and that's the centroid.